Michelin has a long-standing experience in metal 3D printing because Michelin has started to study this technology in 2000. Michelin has developed shapes, particularly complex, for new product lines such as truck and bus and passenger car, such as Cross Climate or Alpin. There was a convergence between the emergence of new software applications, CAD, computer-aided design, and the metal 3D printing technology, which allows the manufacturer to make parts that were not at all feasible on traditional technologies such as casting or forges. In 2010, the decision to scale up production has been taken by Michelin and has led to the creation of a full automated workshop, which is located in France. This workshop is currently producing more than 100,000 shapes per year. All this experience has allowed Michelin to develop a real savoir-faire, know-how, in this kind of 3D metal printing technology. And the question was raised how we can take advantage of this savoir-faire know-how in order to cope with the emerging market of metal 3D printing. Breaking 3D metal printing markets and in such domains as aeronautics, aerospace, luxury, or we can take also defense example, requires and was requiring at this moment of time a huge amount of research and development investment. It's not just about designing machines. We are talking about managing materials such as powders, new powders such as titanium, aluminium. We are talking about creating, developing, and managing new digital solutions to manage the process. We are talking about also managing a complete process of manufacturing, from printing the parts to post-processing. Within this perspective, FIV and its long industrial history was a clear partner for Michelin, and Michelin obviously couldn't have developed by its own so quickly this experience without FIV. Despite the first experiments in 3D metal printing has started more than 15 years ago, we must admit that right now, in fact, we are at the beginning of industrial scale-up for production. We must look at this transformation taking into account the following parameters. First, we need to think, in order to be efficient in terms of use of this technology, we need to think in terms of 3D approach, which means that all the engineering staff, which are based in several companies, must renew their way of thinking, new methods, and it takes some time. It takes some time to get out from the old thinking, which was implied by the old technologies such as casting and forges. Second, we must realize also that 3D metal printing, the metal part, is really an industrial process where we need to manage carefully the powders. There will be some impact on the choice of the powders, on the quality of the final product. We need, of course, to manage carefully the printing by itself, so that means to manage the laser and all the fusion around. And we need also, and sometimes it's forgotten, we need also to carefully manage the post-processing. And when we are talking about post-processing, we are talking about surface treatment, or we are talking also about pure tooling or post-tooling of the parts. Saying that, another point that we mustn't forget also is that if we want to go in domains such as aeronautics, space, defense, we need to be certified, we need to be qualified, and so there is the question of having some proof of concept which are fully validated for the usage of these domains. We've got some successful experience in this market, mainly medical with dental implants. but we've got also aeronautics. Everybody is aware of the integration of 3D parts in the engine of aircrafts. However, to give you an idea, a study from 2019 made by IM Power has shown that 90% of the parts which have been produced this year were with runs below 1,000 parts per year. 70% of this global market has been produced with runs below 100 per year. Which means what? Which means that most of the applications are still done by the research and technology centers, and we are not yet, as I said at the beginning, in a real, let's say, industrial world. That will come, that's coming, but that's not yet completely started. First, I think that we must admit that the outstanding performance which is given by the design of the parts is not going to be enough. We will need to have business case which will bring this technology on the market. Which means what? Which means that particularly it's an industrial process, so we need to manage it carefully. That starts by health and safety, that starts by repeatability, reproducibility on the machines, and of course there is the question of productivity that must be addressed. All these parameters are going to lead to a creation of savoir-faire, know-how, which is really an industrial know-how that will take some time to acquire. Managing the industrial process of metal 3D printing is not, unfortunately, going to be enough. We are in a world where we are talking about emerging technology, so the technology is not stabilized, which means what? Which means that we need to deal with obsolescence of this technology. The good news is that we've got some solutions on the market based on new digital solutions that will solve or at least postpone the obsolescence questions that is quite often raised. To have the right level of competency of people is for sure a key factor of success in this market. We think about, of course, designers, so the guys who are going to design new forms, new parts, but in order to tackle the industrial issues, we need also to develop savoir-faire and expertise in the method part of the approach. The good news is that the things are moving. That means academics have started to develop some, let's say, trainings, academic trainings regarding this aspect. And we see some newcomers, startups, which has been, let's say, 3D printed, in 3D printed mode from the beginning. So that's moving. The COVID-19 crisis could boost, and has boosted, by the way, the emergence of new solutions using metal 3D printing solutions. If we take the old relocation problematic, we are confident that we are able to build print farms with roughly 20 machines in order to give independence to territories. There is also the question of the strategic independence by providing to the state, any states, the ability to produce, for instance, such critical defense parts, and or to answer to some supply chain resilience issues by gathering close to the customer need both the production devices and the customers. AddUp is a relatively young company because it has been created in 2016, which means that we have fully integrated in our approach all the key success factors I've mentioned previously. We have a unique offer, and we are proud of that, of both providing machines, but also providing and producing parts, which means what? Which means that we are able to develop a strong know-how on the way to make parts, and then we can reintegrate this know-how on the machine's design. The second point is that when we look at the market, what is important is that we have pointed out that our customers didn't yet make their choice. So you've got some guys who are going to be, let's say, on a make solution, for instance, medical. They are going to buy only machines, and they will do the parts by themselves. On the opposite, you've got people who are going to make a choice on only buy, and we are able, with our know-how, to support these guys in their ramp-up. And we've got people who are also in between solution. That means to be between a make and a buy strategy. And we will talk about that later, but Dassault is a very good example. We have definitely strong differentiated strengths. We are providing on the market two kinds of technologies, the power bed fusion and the directed energy deposition technology. We consider that in the years to come, these two technologies will cover roughly more than 75% of the global playground of the market. The new generation of machine we are currently either putting on the market or that we are still designing are completely designed to answer industrial questions. The first thing is that these machines, of course, will answer to health and safety, which is really important. But we will offer some tailor-made solutions to our customers. For instance, and I can take several examples, a customer could have several expectations regarding productivity. So we will be able to deliver to this customer either one laser, low productivity, or 4 lasers, all working together, providing a very high level of productivity. We are also providing machines which will be, let's say, operational independently of the choice of the powder. We know that the choice of the powder is critical regarding, for instance, the surface quality at the end of the process. And so that's why we promote either fine powder, which will deliver real outstanding performance in terms of quality of surface, or medium powder, which is the main powder on the market right now, with the same machine. The other point which is really important also is that if we want to tackle the obsolescence issue, we need to have new upgrade of the machines independently of, let's say, very cash and hard solutions. So we need to develop digital solutions which will allow, with the same technology or nearly, to multiply by 2, by 3, or by 4. We've got some tests right now with multiply by 4 productivity KPIs. Regarding part production, we are scaling up the production in Europe, and we've got roughly 40 machines, 40, which are currently producing parts, which means that we are among the top 3 service bureaux in Europe. We've got a lot of proof of concepts going on, but we have started also to have short series with some key players, just like Stellantis, for instance, and which is important because we are moving to a more industrial step. We have also decided to implement in Cincinnati area, in US, a shop in order to demonstrate what we are able to do in terms of parts, which is fully mandatory to attack the US market. I can give you a few examples of success we have in parts or machines. We are currently working on the medical side with Wright Medical, where we have installed 2 machines in their facilities to produce implants. But we are also working with Dassault in order to elaborate with them with the first full automated workshop for aeronautics. Last but not least, we have also a strong partnership with Alpine Racing and Ferrari in Formula One, and of course Michelin. Michelin will be one of our first customers for the new generation of machine. Productivity gains are outstanding. And we are able right now to make some sipes and molds parts at a level that was not able to be reached before. Michelin is reaping all the benefits of AddUp expertise.